This is the first lecture on vectors, which is from class 12 maths chapter 10, and in this video I am going to discuss all the basic concepts of all the topics required in this chapter, and starting with the first vectors. What is a vector? Vector is any quantity which has both magnitude and direction. Like example, weight we know, any body mass, say body of mass m, weight is always acting vertically downward, so it has a definite direction, it has a definite mass and definite direction, definite magnitude as well as definite direction. So weight is a vector quantity, but one condition is there: any quantity which has both magnitude and direction, and it must satisfy the vector law of addition. This one we need more explanation in detail in physics, but in maths we don't need much. Only we'll keep in mind a quantity which has both magnitude and direction is a vector quantity. The second topic is any vector can be represented by a directed line segment. Say this is a line segment with a definite direction. It is representing a vector. We can represent a vector because when we draw a line segment with a direction, there are two things. One is the length of the line segment, another is direction. And in vector also we have seen there are two things. One is magnitude, another is direction. So direction of the line segment representing the direction of the vector, and the length of the line segment giving the magnitude of the vector. So any vector we can represent it by a directed line segment. So this is a vector A, this is vector another vector B, this is another vector C, like this. The third point here is any vector can be written in terms of ijk. Now what is ijk? Ijk are, say this is x-axis, this is y-axis, this is z-axis. We have the coordinate idea, and along x I is a unit vector, I cap. Along y j is a unit vector and k is a unit vector along k cap, along z. They are mutually perpendicular. Along x I, along y j, along z k, they are mutually perpendicular. Angle in between each two is 90 degree. Angle between I j is 90, angle between I k also 90, j k also 90. Now any vector, say this is a vector A, we can write in terms of I j k. Example, say A equal to 2i plus 3j minus 4k. Any vector we can write in terms of ijk like this, where 2, it is like this. Say this is x. If we draw projection perpendicular from the endpoints of the vectors on x, this along x is 2 units. 2i meaning is along x it has projection 2 units. Same way, if we draw projection y on y-axis, it has 3 units, and along z projection 4 units in the negative direction. That is the meaning. Any vector we can write in terms of ijk like this. Coefficient of I is the projection of vector on x-axis. Coefficient of j is the projection of vector on y-axis, and coefficient of k is the projection of the vector on z-axis. Maybe in negative direction, maybe in positive. Here minus 4 means it is in the negative direction, because coordinates we have the idea. X dash is there in the negative direction. Y is in the positive, y is also in the negative direction. So any vector can be written in terms of ijk. A is a vector, say B is another vector, say 3i minus 2j plus 4k, etc. So any vector can be written in terms of ijk. The next topic is point 4, addition and subtraction of vectors. Corresponding components. Components means ijk. Corresponding components are added or subtracted. I have taken an example. A is a vector, B is a vector, and I am finding A plus B. So this is A, this is B. I have to add the two. Now corresponding components, I and I will be combined together. Maybe added, maybe subtracted. It depends on the sign. Here 2i plus 3i. 2 plus 3 is 5i. And minus 3j plus 4j is plus 1j. Plus 4 plus 2 is plus 6k. So this is how we add or subtract vectors. Corresponding elements may be added, may be subtracted. It depends on the sign of the components. Then next topic is magnitude of a vector. Taking an example, A, xi, yj, zk. Then its magnitude. Magnitude is like this: A sum of square of corresponding components, coefficient of I square, coefficient of j square, coefficient of k square, sum of square of corresponding components of that means coefficients of I, coefficient of j, coefficient of k, sum squares. I have taken an example A, then its magnitude we represent by modulus sign. Magnitude, it is coefficient of I square plus coefficient of j square plus coefficient of k. Coefficient of k here minus, so when coefficient is negative you keep inside bracket. So if we simplify, it is 9 plus 4 plus 16 square root of 29. So this is how we find magnitude of a vector. Magnitude is also called length of the vector. So we have learned addition and subtraction of vectors in which corresponding elements are added or subtracted, and magnitude or length of a vector. This is how we find the magnitude of a vector. The next topic is unit vector. Any vector of length, that is magnitude, is equal to 1 unit is called a unit vector. Mathematically, how do you find unit vector? Along any vector A is given by like this: A cap is equal to vector divided by its magnitude. To find unit vector, we have to divide the vector by its magnitude. Magnitude just now we have learned how to find. I am taking an example. If A is equal to 2i plus 2j plus 1k, first we will find its magnitude. Magnitude we know, sum of square of the corresponding sum of square of coefficients of I, j, k. 2 square, 1 square. It will be 9, that means 3. Square root of 9 is 3. So unit vector. Now we can find unit vector along A. It will be A cap is equal to vector divided by its magnitude. That means vector is here 2i plus 2j plus 1k, and magnitude I have got 3. So vector divided by magnitude gives the unit vector. So it will be 2 by, we can simplify more, we can write it 2 by 3i, again 2 by 3j, and 1 by 3k. So this is how we find a unit vector. Any vector divided by its magnitude. Remember, you are writing whenever you get a cap, a above sign is cap means it is a unit vector, and a above arrow mark means it is any vector. It is a vector of any magnitude, and when it is a cap means its magnitude is equal to 1. Remember, any vector, unit vector, magnitude is always 1. So this is about a unit vector. Next is displacement vector. Displacement vector, whenever there will be 2 points given, I am taking an example. Say A is equal to 2 minus 3, 4. B is equal to say 1, 5, 3. Then joining the 2 points, we will have 2 vectors. One is from A to B, one vector, and same way from B to A, another vector. That is called displacement vectors. So how we will find A to B? A to B, we will find it is like this. Remember, second minus first. Actually, it is called position vector of second minus position vector of first. Because any vector gives the position of the point, called position vector. I am not going to explain much about position vector. So you memorize like this only. Whenever you get 2 points given and you are finding the vector joining the 2 points, displacement vector, it will be second minus first. Actually, there will be 2 vectors. One is from A to B, another is from B to A. B to A also we can find it. And it is second minus first. And second and first you will see here in the order of writing. Second is B, you are writing here. So B, it is 1, 5, 3. So it is 1i, 5j, 3k. Remember, in question it may be given without ijk. Without ijk means it is called coordinate form, or it may be given in ijk form also, but while writing we must write in ijk. So here second minus first. First is A. A is 2 minus 3 plus 4. And if we simplify now, 1 minus 2 is minus 1i, 5 plus 3 is 8j, 3 minus 4 minus 1. Okay. So this is how we find position vector. Same way you can find out from B to A. Again, position vector of second minus first. Here will be second A and B will be first. So remember, whenever 2 points given like this, we can find the position vector, sorry, displacement vector. The next topic is direction ratios and direction cosines. I am explaining with an example. A vector A I have taken 3i, 2j and minus 1k. Its direction ratio. Direction ratios are the coefficients of ijk, 3, 2 and minus 1. The coefficients of ijk, that means only the numbers. These are called the direction ratio. And then you will find out the magnitude of the vector, which we have learned just now. 3 square plus 2 square plus minus 1 square. And it will be 9 plus 4 plus 1 is equal to square root of 14. And then direction ratios are the coefficients 3, 2 and minus 1. The coefficients are called the direction ratios of the vector, and direction cosines are found like this. Direction cosines are this direction ratio is divided by magnitude of the vector. 2 by magnitude of the vector, direction ratio, that is minus 1 by magnitude of the vector. These are called direction cosines. Now what is the significance? I am just explaining in simple way. If a vector, this is the vector say A, which we have written here, this vector say this is A, it is making, definitely any vector will make angles with I, J and K. I, J, K means along x axis, along y axis, along z axis. So this is making angle alpha with x axis, beta with y axis, and with z axis say it is making angle gamma. Then this direction cosines are representing this cos alpha, cos beta and cos gamma. These are the direction cosines, the physical significance, geometrical significance, and which are also represented by L, M and N. Direction cosines also we represent by L, M, N in general. And remember, L square plus M square plus N square will always be equal to 1. That means cos square alpha plus cos square beta plus cos square gamma is always equal to 1. You remember this result because there are many questions which we solve by this concept. So this is about direction ratio and direction cosines. Direction ratios are the just coefficients of ijk, the numbers, only the numbers, and direction cosines are divided by magnitude. The direction ratio is divided by magnitude. And this is the physical significance of direction cosines. The next point is about position vector. See, any point which we have learned in coordinates, say coordinate geometry we have learned, any point, say point P is 2, 3, 4. Then this point we can also write in vector form 2i plus 3j plus 4k. That means every point can be written in vector form, and that vector is called position vector. Then what is position vector physical significance? Position vector physical significance is from origin you draw a line and give direction to the line, and we know every directed line segment is a vector, and this is the vector. If you represent this vector by A, this is the vector. Vector A, position vector, it is a vector whose starting point is origin. From origin to the point, from origin to the point is given by the position, which is the coordinate, and it is called position vector of the point. Position vector, you remember, it is a vector starting from origin ending at the specific point, which is called the position vector. And when you remember, when you physical significance, when you any point representing by a vector, then you remember this 2 is the projection along x, 2 units, projection along y, along x means along I cap, along x unit vector is I cap. So 2 is the projection along x, 3 is the projection along y, and 4 is the projection along z. The projection may be in positive direction, may be in negative direction also. So this is the idea about position vector. So whenever you say position vector, remember it is a vector starting from origin ending at the point which you are considering. So this is about position vector. The next topic is section formula. Section formula, we have three points here, 3 parts: internally, externally and midpoint. Section formula, the geometrical meaning I am explaining at first. If one point position vector is A, another point position vector is B, and you want to find a point in between, say point P, and point P, it is on the line joining the points A and B, and in the ratio say m is to n. this side given m, this side given n, m is to n ratio. Then how we will find this point P? Point P will be given by m into b plus na divided by m plus n. Similar formula you got in also coordinate geometry. MB, remember MB opposite MBNA divided by m plus n. And then the same formula again for external division. Internal division means point P is lying in between A and B, internally, inside. Now externally, say this is point A, this is point B, and you want to find a point, say Q, outside. Externally means outside. It is not in between A and B, it is outside. On the line, but outside. Then from A, this distance is M, and from B, this distance is N. Then the same formula, it will be point Q will be given by MB, opposite. MB plus NA by M plus N. It will not be plus, it will be minus. For external, formula is negative. Exactly the same formula but negative, but geometrical significance is different. You see, from A distance is M, from B distance is N. There are some questions in higher level questions which are solved by geometrical concept. So you must have clear idea about M. M is from A, N is from B, and when you write MB opposite, MBNA by MN. For internal positive, for external negative. And then midpoint. Midpoint is like this. If one point is A, another point is B, and you are exactly finding the midpoint, middle point, say P, in between A and B, then the midpoint P will be given by A plus B divided by 2. A plus B divided by 2. This formula, this is same as the internal formula. Here only M is 1, N is 1, because it is in the middle, 1:1 ratio. 1:1, or you can write 2:2, equal ratio. 1:1 is better. 1:1 you take, M is 1, N is 1, then this formula only reducing to this, A plus B divided by 2. So this is the idea about the section formula, dividing a point, dividing in certain ratio, and if the point is inside, that is called internally, this is the formula. Point is outside, then externally, this is the formula. And if the point is in the middle, that is called midpoint, this is the formula. The next is about product of vectors, and the first is scalar product, or also called dot product of vectors. The definition is like this: if two vectors A and B in between making an angle theta, then their dot product is defined like this: A dot B is magnitude of A, magnitude of B into cos theta. Theta is the angle between the two vectors. So this is the definition of dot product. And at first I'll apply this definition to IJK. IJK we have learned like this. There are three mutually perpendicular unit vectors. I is along x-axis, J along y, and K along z-axis. They are three mutually perpendicular. Mutually perpendicular means angle between each two is 90. IJ angle 90, JK angle 90, KI also angle is 90. Now, this definition, I'll take different, IJK, I'll take different unit vectors. First, I dot J. According to this definition, it is magnitude of I, magnitude of J into cos of the angle. I and J angle is 90 degree. So this is the definition we have applied here for I and J. Now magnitude, you see, IJK are unit vectors, and IJK are unit vectors, so their magnitude is 1. We have learned the definition of unit vectors. Any unit vector magnitude is equal to 1. So magnitude of I is 1, magnitude of J also 1, and cos 90 value is 0. So ultimately we are getting 0. Now the same definition I'll apply again. Same I, J, K. I'll take same vector I dot I, and this definition I'll apply now. I dot I, it is A is I, B also is I. So this is the definition I'm applying. Magnitude of I into magnitude of I again into cos I and I with itself. I with itself, the angle making is 0 degree. Then magnitude of I is 1, again 1, and cos 0 value is 1. So ultimately I'm getting 1. Similarly, if I find J dot J, will get value 1, K dot K also will be equal to 1. So you see we are getting I dot I is 1, J dot J is 1, K dot K also 1. But when here we are taking different vectors, I, J value coming 0. Same way, if we find I, J 0, J, K, J dot k also will be equal to 0, ki will also be equal to 0. So you remember like this, whenever you take two different unit vectors ijk, if you take same, then value is 1, and if you take different, value is 0 for dot product. Now using these concepts, if I find I'll take an example how to find dot product. Say A is one vector, say xi, yj and zk, and B is another vector, say x dash i, y dash j and z dash k. I want to find their unit dot product. Then A dot B is equal to first dot second z dash k. Then what we have learned here is, see, if different ij value 0, jk also 0, ki also 0, and here if we take same, then 1. Now we'll multiply, but in between there is dot. First it will be x dash, and I dot I value is 1. Now if I multiply first with second, what I am getting? I dot j, and we have discussed here I dot j value is 0. So first with second I will be 0, and first if I multiply with third, again I dot k also value will be 0. So with first term done, then with second term j I again 0, and then only we will have j dot j value is 1. So z dot j coefficient will be y into y dash, plus same way we will get only z dash z into z dash, k dot k value is 1. I am taking an example. If we have two vectors, say 2i plus 3j plus 4k, you are finding dot with say 3i minus 2j plus 5k, you are finding the dot product. Then first into first, 2 into 3, coefficient of I with coefficient of I, plus coefficient of j with coefficient of j, plus coefficient of k with coefficient of k. Because I dot I is 1, so coefficient of I and I will have, and I with j 0, I with k also 0. Same way j with j will be 1, so coefficient of j multiplied, then similarly coefficient of k multiplied with coefficient of k, and if we multiply we will get the answer. So this is how we find dot product between two vectors. Now more about dot product. This is the definition of dot product which we have discussed just now. Now if I take a vector A and I'll apply this definition for A with A itself. That means A is A, B also is A. Then what we will get? Right side, magnitude of A, magnitude of B is again A, cos theta. Theta is the angle made by vector A with A itself is angle 0. That means magnitude of A into magnitude of A, cos 0 value is 1. So we are getting magnitude of A into A, that means magnitude of A square. So we are getting vector A dot with A itself is magnitude of A square, and this is a very important result. There are many questions, any questions related to magnitude is solved by this concept. You have to remember this. Now second point, the same definition we have learned. A dot B is magnitude of A, magnitude of B, cos theta. Two vectors A and B. Angle made is theta in between. A dot B, magnitude of A, magnitude of B, cos theta. This is the definition. Now if I change the order, if I make it B dot A, it will be magnitude of B, magnitude of A into cos theta. Now you see the right side is exactly same. For AB and BA, the right side is exactly same. That means A dot B is same as B dot A. So this is an important result. Again, memorize, it is required for solving questions. A dot B is equal to B dot A. Now, if I take two vectors perpendicular to each other, A and B, then I'll apply this definition. A dot B definition is magnitude of A, magnitude of B, cos theta is the angle between them is 90 degree, and cos 90 value is 0. That means magnitude of A and magnitude of B into 0, right hand side is finally 0. That means if two vectors A perpendicular B, then their dot product is equal to 0, and the reverse also will be true. If dot product 0, vectors will be perpendicular, the reverse also will be true. So this is another important result for two vectors perpendicular. And remember, perpendicular, another name is orthogonal. Perpendicular, another name is orthogonal. So if two vectors are orthogonal or perpendicular, then their dot product is 0. Then fourth point, dot product. If two vectors making angle A and B in between, and we want to find the angle between the vectors, then we can use this definition. From this definition only we can find cos theta. From this definition, if we find cos theta, what we will get? Cos theta, other terms transferring to the left side, it will be A dot B by magnitude of A, magnitude of B. So this is the definition of cross product, and we can use it for finding the angle between the two vectors. We know, we have learned how to find dot product, we have learned how to find magnitude of vectors, so easily we can find the angle between the two vectors if the vectors are given. Then next point, this is vector B, this is vector say A. Then from the endpoints of vectors A, if you draw perpendicular, then this distance is called projection of vector A on B. Projection of vector A on vector B, and it is given by A dot B by magnitude of B. Projection of A on B is given by A dot B by magnitude. We have learned how to find dot product, we have learned magnitude, so we can easily find out projection of A on B. Similarly, projection of B on A, we have to just reverse the interchange the vectors A and B. So this is about dot product. The next is about cross product, which is also called vector product. Now two vectors A and B in between making an angle theta, then their cross product is defined like this: A cross B. You don't read it as into. In vectors there is no into. In vectors product only either dot or cross. So this is cross product. You have to read it like A cross B. It is given like this by magnitude of A into magnitude of B sin theta. In dot product it was cos theta, and cross product is defined like this. It is sin theta, and n cap is there. The what is n cap now? N cap is like this. It is a unit vector which is perpendicular to both A and B. We have to mention here where n cap is a unit vector which is perpendicular to both A and B. So A cross B direction is given by n cap. So A cross B is a vector. Remember, A cross B is a cross product gives a vector, and dot product gives a scalar. When you find dot product, you will get a number. It is a scalar. And when you find cross product, answer will be a vector. So A cross B vector, its direction is given by n cap. That means it will be A cross B, the whole vector, it will be in the direction of n cap. It will be something like this, parallel to n cap. In the direction of n cap, the vector A cross B will have the direction in the direction of n cap. So this is about the definition of, this is the definition of cross product of two vectors. Now at first I'll apply this definition for ijk. At first I am taking I with I itself. So if I take I with I itself cross product, that means here A is I, B also is I. So I'll write in the right side, A is I, B also is I. Sin theta, angle made by I with I itself, angle is 0 into n cap. Definition is they are having n cap. So magnitude of I is 1, which we have discussed. Ijk are unit vectors, their magnitude 1. J, again I magnitude 1, sin 0 angle is 0 into n cap. That means 0 into anything, it will be 0. So I cross I is 0. Same way, if we find J cross J, we will get again 0, and K cross K, we will also get 0. So remember, whenever we get same vectors, cross product is coming 0. Now this again I'll apply for, if I apply for difference, say I cross J, same definition. here A is I, B is J, then magnitude of A, magnitude of B, sine theta. I and J angle is 90. They are mutually perpendicular. We have the description. I, J, K are mutually perpendicular. So angle between I and J is 90 degree. So this is 90. And N cap. Magnitude is 1, J also 1, sine 90 value is 1. And N cap is perpendicular to I and J. Listen carefully. N cap is perpendicular to I and J, and perpendicular to I and J is K vector. K cap, unit vector K cap. So we are getting K cap. That means we are getting I cross J is equal to K. And for memorizing this, I am giving a technique like this. You will memorize like this. I, J and K. You take anti-clockwise direction and positive. You remember like this. And when you take I, J, K, different vectors, if you take clockwise direction, then negative. You memorize like this. What is the meaning? Meaning is like this. See, anti-clockwise. I, J. I cross J, positive. I cross J will be equal to K. I cross J is K. We are taking anti-clockwise direction, anti-clockwise. I cross J is giving K. Then JK will be I. And KI will be equal to J. K cross I is equal to J. And if I take clockwise, we will get negative. Say IK. I cross K will be equal to minus J. KJ. K cross J will be equal to minus I. JI. J cross I equal to minus K. So you remember, when you take two different vectors, I, J, K, product of any two is the third one. I, J is K, J, K is I, like that. Cross product of any two is the third. And when we take anti-clockwise direction, we get the positive result. When we take the clockwise direction, we get the negative result. So this is the technique, this is the tricks how to memorize about the unit vectors I, J, K, about their cross product. Now, using all these concepts, these are the concepts which are coming only from the definition of A cross B. All these concepts are coming from the definition of cross product. Now, using all these concepts, the cross products are found by an arrangement which is the determinant. I am giving now an example. Using the concept of cross product, the cross product between two vectors is found by arrangement which is the determinant. It's like this. We will draw vertical lines, and in between the determinant which we have done in chapter 4, class 12 maths. Now, first row is given by I, J, K. The second row is the coefficient of first vectors 2, 3, minus 2, and next coefficient of next second vector 3, 1, 4. This is a determinant we know how to expand. It's third order determinant. Expanding using first row, I minus J plus K. Using the first row, I plus J minus K plus. And then when I, then you close the row and column containing I. Both row and column containing I will close. The remaining will make this determinant. This is actually a second order determinant. And for J you close row, column, and row will remain 2 minus 2, 3, 4. And for K again we have to close in the same way. Remaining is 2, 3, 3, 1. And these all are second order determinant. We know how to find by multiplying this direction minus this direction, cross multiplied. So it will be I into this direction, 3 4 the minus 1 into minus 2 minus J into same way we can multiply. It will be 2 4 the 8 minus minus plus 3 2 the 6 plus K into 2 1 the 2 minus 9. We can easily find out. So it is I into 12 plus 2, J into 14, K into minus 7. So 14I minus 14J minus 7K. So you see, whenever we find the cross product, the resulting, what we get the answer, it is a vector. Cross product is a vector, and dot product when you find, you will get a number which is a scalar. So cross product of two vectors is a vector. So this is how we find mathematically the cross product. This is this arrangement, that is the determinant which is made by using all the concepts which I have discussed now about the definition. About cross product, the definition we have just now learned. A cross B, magnitude A, magnitude B, sin theta n cap. N cap is a unit vector which is perpendicular to both A and B. Like this. If A is this, B is this, n cap will be perpendicular to both A and B, like this. A, B, n cap, like this, perpendicular to both A and B. That is the definition of cross product. Now, this cross product, if I apply for two parallel vectors also called collinear in the same line, like this, A and B is along the same line, maybe in the same direction, maybe in the opposite direction. You need more explanation in detail for physics, but here this much enough for maths. So if I apply this definition for two parallel vectors A and B, then right side magnitude A, magnitude B, sin theta, theta will be 0 degree here, because angle, when two vectors are in the same direction, parallel or along the same line, their angle is 0 into n cap, and sin 0 value is 0, so ultimately the right side is 0. So remember, when two parallel vectors or collinear vectors, their cross product is 0. Now if I apply this definition for a vector A with A itself, A cross A with A itself, that means A is A, B also is A, and I'll apply the definition. It is magnitude A into magnitude A into sin 0 degree, vector A with A itself, angle made is 0, by into n cap. So sin 0 is 0, ultimately right side 0. So remember, A with A itself, cross product is always 0. It is a vector, 0 vector. This right side, it is a vector, because this n cap is giving the direction 0 vector. It is not algebraic 0. So this is the idea about cross product. And then application of cross product. There are some applications cross product can be applied. First is area of triangle. If two vectors A and B given, then these two vectors we can complete a triangle. Then the triangle made by two vectors A and B, their area is given by cross product. Cross product we have learned how to find, and then magnitude of cross product gives the area of the triangle. And then if area of parallelogram, again, if two adjacent sides of parallelogram, this is vector A, this is another vector B, adjacent sides, they are starting from the same point, and then with these two vectors we can make a parallelogram. Then area of parallelogram, you see in this parallelogram we have two triangles. If we see this concept, if we draw the diagonal, we have two triangles. So for area of triangle we have half is there, half of A cross B magnitude. And then for a parallelogram we have two triangles, so this formula only we have to multiply by 2. So if we multiply by 2, then half and 2 will get cancelled, so area of parallelogram will be only A cross B magnitude. A cross B, cross product we have learned how to find, magnitude also we have learned how to find, so we can find out the area of parallelogram. Then here, area of parallelogram whose diagonals are given. Here sides, adjacent sides, but in this case diagonals. So we will draw a parallelogram in which diagonals are represented by, one is by D1 vector, another is by D2 vector. Then again same way we will find cross product. Two vectors given, we will find out their cross product, we will find their magnitude and multiply by half. That will give the area of parallelogram when the diagonals are given. So you can see here, compare area of triangle formula half is there, and area of parallelogram with diagonals also half is there, and area of parallelogram with sides half is not there. So these are some applications of cross product on vectors. So this is the end of this lecture. Almost all the concepts needed in maths given about the vectors, and we will have more videos for solving exercise questions.